The Inconceivable Mathematics of Transcontinental Annihilation. February 16, 1945. The Imperial Palace Grounds, Tokyo. Colonel Saburō Sakai, Japan's second highest scoring ace with 64 confirmed victories, stood on the observation deck of the Army Air Defense Headquarters and stared at the impossible sight unfolding above his homeland's capital. Through his binoculars, he tracked a formation of silver aircraft with distinctive bubble canopies and sleek angular wings that seemed to slice through the winter air with mechanical precision. These were not the twin-engine P-38 Seconds or stubby F-4us he had battled over the Pacific atolls. These were single-engine fighters. American single-engine fighters, operating 1,500 miles from the nearest Allied airbase, escorting a stream of B-29 Superfortresses with the casual confidence of aircraft patrolling their own territory. Sakai lowered his binoculars and felt something he had never experienced in 4 years of aerial combat: the cold certainty of technological impossibility. American fighters were not supposed to be capable of reaching Japan. The mathematics of fuel consumption, engine endurance, and operational range had been carefully calculated by Imperial Navy engineers, and those calculations had pronounced such missions aeronautically impossible. Yet there they were, silver death incarnate, turning lazy circles above the Emperor's palace as if range and fuel consumption were merely theoretical concepts that American engineers had chosen to ignore. What Colonel Sakai witnessed that February morning was not simply the arrival of another American fighter aircraft, but the manifestation of technological transcendence so complete that it redefined the fundamental mathematics of aerial warfare. The North American P-51 Mustang represented something more terrifying than superior firepower or advanced avionics. It was the physical embodiment of American engineering's ability to solve problems that Japanese scientists had declared mathematically unsolvable. While Japanese designers had spent years calculating the theoretical limits of single-engine fighter range, American engineers had systematically demolished those limits through the relentless application of advanced metallurgy, precision manufacturing, and aerodynamic innovation. The P-51 Mustang was not merely an aircraft. It was a flying declaration that American industrial civilization had achieved the capability to project lethal force anywhere on Earth, with mathematical certainty that bordered on science fiction. The engineering specifications that enabled the P-51's transcontinental reach represented a systematic revolution in aircraft design that Japanese technicians could barely comprehend. The Mustang's Packard-built 1650 Merlin engine, built under license from Rolls-Royce, but refined through American manufacturing precision, produced 1,695 horsepower, while consuming fuel at a rate 23% more efficient than any equivalent Japanese power plant. The engine's advanced supercharging system maintained maximum power output at altitudes exceeding 25,000 feet, where Japanese fighters experienced significant performance degradation. But the true engineering miracle lay in the aircraft's internal fuel capacity: 269 gallons housed in carefully designed internal tanks, supplemented by external drop tanks that could extend total fuel load to 489 gallons. This represented more fuel than most Japanese fighters could carry, even when configured with every available external tank. Yet the P-51 achieved this capacity while maintaining superior performance in speed, climb rate, and maneuverability. The mathematical impossibility of the P-51's operational range became clear when compared to Japanese fighter capabilities. The standard A6M0, Japan's premier long-range fighter, could achieve a maximum range of 1,929 miles under ideal conditions with external fuel tanks and careful throttle management. This had been considered exceptional performance, enabling Japanese fighters to escort bombers on long-range missions throughout the early war. The P-51D Mustang, with internal fuel only, could achieve 1,650 miles range, nearly matching the Zero's maximum performance without external tanks. With external fuel, the Mustang's range extended to 2,300 miles, permitting round-trip missions from Iwo Jima to Tokyo, with sufficient fuel remaining for extended combat over target areas. But the true shock lay in the aircraft's combat radius with full armament: 1,000 miles, meaning P-51 Mustangs could fight effectively at distances where Japanese fighters would be operating at the absolute limits of their endurance. The production statistics surrounding the P-51 program revealed American industrial capabilities so vast that Japanese planners initially dismissed intelligence reports as propaganda fabrications. North American Aviation's Inglewood facility began P-51 production in May 1941 with a modest order for 320 aircraft. By February 1945, when P-51 Mustangs first appeared over Tokyo, total production had reached 14,819 aircraft, with manufacturing rates exceeding 500 units per month. The Inglewood plant alone was producing one complete P-51 every 3.2 hours, operating around the clock with 3 complete shifts. Additional production lines at Dallas and Kansas City brought total P-51 production capacity to 1 aircraft every 1.4 hours by early 1945. Japanese intelligence officers, analyzing captured production documents, reported to Imperial headquarters that American P-51 production rates exceeded Japan's total fighter output of all types by a factor of 2.3 to 1. The contrast between American and Japanese manufacturing capabilities extended beyond mere production numbers to encompass fundamental differences in industrial philosophy and resource allocation. Each P-51 required approximately 2,200 man-hours to complete, utilizing precision tooling and standardized assembly techniques that ensured consistent quality across thousands of aircraft. Japanese fighter production, constrained by shortages of skilled labor and precision machinery, required an average of 8,700 man-hours per aircraft, while achieving quality standards that varied dramatically between individual machines. American production lines incorporated quality control systems that rejected components, failing to meet specifications within tolerances measured in thousandths of an inch. Japanese production, desperate to maintain output despite material shortages, increasingly accepted components that met minimum functional requirements but fell well short of optimal performance standards. The metallurgical advances incorporated into P-51 construction represented American technological superiority in its most fundamental form. The aircraft's aluminum alloy structure utilized advanced heat treatment processes that provided strength-to-weight ratios 18% superior to equivalent Japanese materials. The propeller employed aluminum alloy blades with steel leading edges, providing durability that Japanese propellers could not match. Most significantly, the P-51's fuel system incorporated self-sealing tank technology, so advanced that tanks could sustain multiple machine gun strikes without catastrophic fuel loss. Japanese fighters, constructed with conventional fuel tanks to save weight and materials, remained vulnerable to single hits that could drain fuel systems within minutes. The engine technology that powered the P-51's transcontinental missions embodied American engineering philosophy in its purest expression. The Packard-built 1650 represented not merely licensed production of a British design, but systematic American improvement of every component and system. American metallurgy produced cylinders capable of sustained operation at higher pressures and temperatures than the original Merlin specifications. Precision manufacturing techniques achieved tolerances that eliminated the power variations common in hand-fitted engines. The result was an engine that not only produced more power than its British predecessor, but could maintain that power output through extended operation under conditions that would destroy equivalent Japanese power plants. Flight testing demonstrated Packard Merlins operating continuously for 300 hours between overhauls, compared to 150 to 200 hours for the best Japanese engines. The armament systems installed in P-51 Mustangs represented firepower concentration that Japanese pilots found almost incomprehensible. 50 caliber M2 Browning machine guns delivered a combined rate of fire exceeding 4,200 rounds per minute, with each gun capable of sustained operation without the overheating problems that plagued Japanese weapons. The M2 Brownings 50 caliber rounds possessed muzzle velocities of 2,910 feet per second and delivered 13,400 foot-pounds of energy per impact. Japanese fighter armament typically consisted of two 7.7mm machine guns and two 20mm cannon, providing superior individual projectile energy from the cannon, but much lower overall rates of fire. The mathematical relationship was devastating. A P-51 6-second burst delivered more total destructive energy than most Japanese fighters could produce in 30 seconds of sustained fire. The ammunition production supporting P-51 operations revealed the depth of American logistical preparation for global aerial warfare. Lake City Army Ammunition Plant produced 50 caliber ammunition at rates exceeding 2.8 billion rounds annually by 1945, enough to supply every operational P-51 with 25,000 rounds per aircraft. This represented more ammunition than the entire Japanese military could produce in all calibers combined. Each P-51 carried 1,880 rounds as standard load, providing ammunition for sustained combat operations that would exhaust the total ammunition supply of an entire Japanese squadron. The psychological impact on enemy pilots was severe. While Japanese pilots learned to conserve ammunition and fire only when certain of hits, P-51 pilots could engage targets with overwhelming suppressive fire, knowing their ammunition supply was essentially unlimited. The electronic systems incorporated into late production P-51 seconds provided technological advantages that approached science fiction compared to Japanese capabilities. The SCR-522 VHF radio system enabled crystal-clear voice communication over ranges exceeding 200 miles, compared to Japanese radio systems with effective ranges of 15 to 25 miles and voice quality so poor that most tactical communication relied on visual signals. American pilots could coordinate complex tactical maneuvers, receive real-time intelligence updates, and call for assistance while operating over enemy territory. Japanese pilots often flew into combat without reliable communication with ground controllers or other aircraft, relying on predetermined flight patterns that could not adapt to changing tactical situations. The navigation equipment that enabled P-51 seconds to find targets across the vast Pacific demonstrated American technological sophistication in precise, measurable terms. Radio compass systems provided automatic bearing indicators to navigation beacons, while advanced altimeters maintained accuracy within 50 feet at altitudes exceeding 30,000 feet. Most critically, P-51 seconds operating over Japan were equipped with identification friend or foe (IFF) transponders that allowed ground controllers to track friendly aircraft and vector them toward enemy formations. Japanese aircraft possessed no equivalent systems, making coordination between different units extremely difficult, and friendly fire incidents increasingly common as combat intensity increased. The fuel quality available to P-51 operations contrasted dramatically with the increasingly degraded aviation gasoline available to Japanese forces. American 100-octane aviation fuel maintained consistent performance characteristics that enabled engines to operate at maximum power settings for extended periods. The high-octane rating prevented detonation under high manifold pressure, allowing pilots to utilize full emergency power when required. Japanese aviation fuel, increasingly diluted with lower-octane substitutes, as petroleum imports dwindled, often caused engine knock and power loss during high-G maneuvers. Some Japanese pilots reported engines failing completely during combat, unable to sustain the stresses of aerial maneuvering with degraded fuel. The pilot training programs supporting P-51 operations demonstrated American systematic superiority in human resource development. Army Air Force's pilot training produced 7,500 new fighter pilots in 1944 alone, with each pilot receiving an average of 210 hours of flight training before combat deployment. Advanced training programs provided additional instruction in long-range navigation, high-altitude operations, and escort tactics, specifically designed for B-29 protection missions. Japanese pilot training, constrained by fuel shortages and aircraft availability, had been reduced to fewer than 100 hours of flight time. Many replacement pilots received their final training on aircraft so worn that they barely represented combat-ready machines, creating a generation of aviators whose preparation was inadequate for the technical demands of modern aerial warfare. The maintenance and logistics systems supporting P-51 operations over Japan revealed American organizational capabilities that Japanese forces found incomprehensible. Each deployed P-51 squadron operated with spare parts inventories equivalent to 150% of the components required to completely rebuild every aircraft in the unit. Parts availability exceeded 95% for all critical systems, ensuring that mechanical failures rarely resulted in extended aircraft downtime. Maintenance crews were equipped with precision tools, comprehensive technical documentation, and standardized procedures that reduced average turnaround time to 6.2 hours for routine maintenance. Japanese maintenance organizations, operating with parts availability below 40% and improvised tools, required 18 to 24 hours for equivalent maintenance tasks. The strategic implications of P-51 operations over Japan transcended individual combat effectiveness to encompass fundamental changes in the mathematics of aerial warfare. For the first time since Pearl Harbor, Japanese territory was subject to systematic attack by enemy fighters, operating with sufficient fuel reserves to engage in extended combat. The psychological impact was devastating. Japanese civilians and military personnel witnessed American fighters patrolling overhead with the casual confidence of aircraft operating from nearby airfields, despite the reality that the nearest Allied base was 1,500 miles away. The demonstration of American technological capability was so overwhelming that many Japanese observers initially assumed the aircraft were operating from captured airbases on the Japanese mainland. The first major engagement between P-51 Mustangs and Japanese home defense fighters occurred on February 16, 1945, as 73 Mustangs escorted B-29 Mustangs attacking aircraft factories around Tokyo. Japanese interceptors, primarily A-6M0s and Ki-84 Franks, launched from airfields throughout the Kanto region, numbered nearly 150 aircraft, the largest defensive effort mounted over Japan since the war began. The results were catastrophic for Japanese forces. 26 Japanese aircraft destroyed, 34 damaged beyond repair, with P-51 losses totaling 2 aircraft. The kill ratio of 13:1 represented not merely tactical victory, but mathematical proof of American technological dominance over Japan's most experienced home defense pilots, flying the most advanced aircraft available to Japanese forces. Individual combat reports from February 16 documented the systematic nature of P-51 superiority over Japanese fighters. Captain Donald Strait, of the 361st Fighter Group, encountered a formation of 12 Ki-84 Franks climbing to intercept B-29 Mustangs at 28,000 feet. His after-action report described the engagement with clinical precision. Enemy aircraft attempted climbing attack from 6 o'clock position, increased manifold pressure to maximum and easily outclimbed attacking formation, reversed direction, and engaged from superior altitude. First target destroyed by convergent fire from all 6 guns. Aircraft exploded immediately. Second target attempted turning engagement, but P-51 sustained turn rate superior at combat altitude. The report continued for another 800 words, documenting the systematic destruction of 7 Japanese fighters in 12 minutes of combat. The technical performance demonstrated by P-51 Mustangs during the February 16 engagement shocked Japanese pilots who had considered their latest aircraft competitive with American fighters. The Ki-84 Frank represented the pinnacle of Japanese fighter development, featuring a 1,900 horsepower engine and maximum speed of 392 miles per hour. Japanese pilots expected the Frank's superior power-to-weight ratio would provide performance advantages over the heavier American fighters. Instead, they discovered that P-51 Mustangs could outclimb, outdive, and outturn their aircraft at the high altitudes where interceptions occurred. The Mustang's maximum speed of 437 miles per hour, at 25,000 feet, provided a decisive advantage that allowed American pilots to control engagement parameters completely. The range capabilities demonstrated during escort missions over Japan eliminated Japanese tactical advantages that had proven effective against shorter-ranged American fighters. Japanese pilots had learned to avoid initial interception attempts, instead following American formations and attacking during withdrawal phases when fuel consumption limited American combat effectiveness. P-51 seconds, operating with sufficient fuel reserves for extended combat operations, could engage Japanese interceptors immediately upon contact and pursue withdrawn enemy aircraft to their bases. The psychological impact was severe. Japanese pilots found themselves hunted throughout their operational areas by American fighters with apparently unlimited endurance. The systematic destruction of Japanese aircraft production facilities by B-29 seconds, escorted by P-51 seconds, eliminated any possibility of recovering aerial competitiveness through increased manufacturing. The February 16 raid alone destroyed or severely damaged 3 major aircraft factories, reducing Japanese fighter production by an estimated 400 aircraft per month. Subsequent raids, protected by increasing numbers of P-51 escorts, systematically eliminated Japanese aircraft manufacturing capability. By April 1945, Japanese fighter production had been reduced to fewer than 200 aircraft per month, compared to American P-51 production exceeding 600 units monthly. The fuel crisis that gripped Japanese aviation by early 1945 was exacerbated by P-51 escorted bombing attacks on petroleum refineries and storage facilities. Japanese fighters were already operating with severe fuel restrictions when American attacks began systematically destroying the infrastructure required to produce and distribute aviation gasoline. Flight training was reduced to essential familiarization only, with some replacement pilots receiving fewer than 20 hours of flight time in operational aircraft. Combat missions were restricted to essential defensive operations, with pilots instructed to conserve fuel by avoiding extended engagements. The contrast with American operations was stark. P-51 pilots accumulated unlimited flight hours and could engage in extended combat without fuel conservation concerns. The electronic warfare capabilities demonstrated by P-51 seconds over Japan introduced technological dimensions of combat that Japanese forces could not counter effectively. Radio jamming equipment installed in some Mustangs disrupted Japanese ground control communications, preventing coordinated defensive responses. Navigation jamming systems interfered with Japanese aircraft radio compass equipment, causing interceptors to become disoriented during long-range approaches. Most significantly, American electronic intelligence systems monitored Japanese radio communications in real time, providing P-51 formations with advance warning of defensive preparations and allowing tactical adjustments before contact. The night fighter variants of the P-51 introduced capabilities that Japanese home defense forces found impossible to counter. P-51D aircraft, equipped with radar systems, could detect and engage Japanese aircraft in complete darkness, eliminating night attacks as a viable defensive tactic. Japanese aircraft possessed no airborne radar systems and relied entirely on visual acquisition for target identification. American night fighter pilots achieved kill ratios exceeding 8-1 against Japanese aircraft, attempting nocturnal interception missions, effectively ending night operations as part of Japanese home defense strategy. The psychological warfare impact of P-51 operations over Japan extended far beyond immediate combat effectiveness to encompass systematic demoralization of Japanese military and civilian populations. American fighters operating with apparent impunity over the Emperor's Palace, major cities, and sacred sites demonstrated the complete failure of Japanese home defense capabilities. Radio intercepts revealed growing panic within Japanese military communications as pilots reported the apparent impossibility of effective interception against American escort fighters. Civilian populations, witnessing American fighters patrolling overhead during daylight hours, began to understand the mathematical certainty of Japanese defeat. The captured pilot testimonies from Japanese aviators shot down by P-51 seconds during home defense operations revealed the depth of technological shock experienced by enemy forces. Flight Petty Officer Yasuo Kuwahara, shot down over Tokyo Bay on March 9, 1945, provided detailed testimony about Japanese pilot morale and tactical assessment. We were told that American fighters had limited range and could not escort their bombers all the way to Japan. When we first encountered them over Tokyo, many pilots thought they must be operating from captured bases on our mainland. The alternative that American aircraft could fly 1,500 miles, fight over our capital, and return to their bases seemed technically impossible. But they kept coming, day after day, with fuel enough to hunt us to our own airfields. The strategic bombing campaign, enabled by P-51 escort operations, achieved results that individual combat victories could not accomplish. Protected B-29 seconds systematically destroyed Japanese industrial capacity, transportation infrastructure, and urban areas with mathematical precision that eliminated Japanese ability to sustain organized resistance. The escort missions flown by P-51 seconds enabled the destruction of 2.3 million tons of Japanese shipping, 40% of urban area in major cities, and virtually all aircraft production facilities. By July 1945, Japan's ability to produce, fuel, or pilot military aircraft had been reduced to levels insufficient to mount meaningful defensive operations. The kamikaze campaigns that characterized Japanese operations during 1945 represented tacit admission of conventional air combat's futility against P-51 protected bomber formations. Japanese commanders, recognizing that traditional interception tactics resulted only in pilot and aircraft losses without corresponding damage to enemy forces, redirected their remaining aircraft towards suicide attacks. Even these desperate tactics proved largely ineffective against P-51 escort formations that could intercept and destroy heavily loaded kamikaze aircraft before they reached their targets. The escort fighters' superior speed, climb rate, and firepower made systematic interception of suicide attacks routine rather than exceptional. The technological evolution of P-51 variants throughout 1945 demonstrated American ability to continuously improve weapon systems while maintaining massive production rates. The P-51 hours model, introduced in June 1945, incorporated a more powerful engine producing 2,218 horsepower, reducing weight through advanced construction techniques, and achieving maximum speeds exceeding 487 miles per hour. Advanced variants included rocket armament, improved electronic systems, and extended-range fuel tanks. Japanese aircraft showed virtually no technical evolution during the same period, with late-war variants often inferior to earlier models due to material shortages and simplified construction methods required for mass production. The pilot experience differential that had developed by mid-1945 made Japanese interception attempts virtually suicidal regardless of aircraft performance. American P-51 pilots averaged 340 hours of flight training before combat deployment, with many receiving additional combat experience in earlier aircraft types before transitioning to the Mustang. Japanese replacement pilots received fewer than 60 hours of total flight training, with much of that time in aircraft barely capable of flight due to maintenance problems and fuel quality issues. The inexperience was compounded by inadequate gunnery training. Many Japanese pilots had never fired their aircraft's weapons before entering combat, while American pilots received extensive air-to-air gunnery training using live ammunition. The maintenance crisis that affected Japanese aviation by late 1945 eliminated operational effectiveness even among aircraft that remained technically airworthy. Parts shortages forced extensive cannibalization, with functional aircraft stripped of components to keep others operational. Many Japanese fighters operated with engines overdue for major overhaul, weapon systems partially functional, and radio equipment inoperative. Flight safety became secondary to maintaining any operational capability at all. American P-51 maintenance organizations, supported by unlimited spare parts and precision tools, maintained aircraft availability rates exceeding 85% throughout the final year of the war. The final major air battle over Japan occurred on August 13, 1945, 2 days before surrender, as Japanese fighters attempted to intercept B-29 seconds, attacking transportation targets near Tokyo. P-51 escorts encountered approximately 60 Japanese fighters in what became the last significant aerial engagement of the Pacific War. The results summarized 4 years of technological and industrial development, 18 Japanese aircraft destroyed, 0 American losses. Japanese pilots, flying worn-out aircraft with minimal fuel and inadequate training, were systematically destroyed by American pilots operating aircraft that represented the pinnacle of wartime technological development. The mathematical certainty of P-51 superiority over Japanese home defense forces was demonstrated not merely through superior combat performance, but through the systematic elimination of Japanese capability to sustain aerial operations. Total P-51 production reached 15,586 aircraft by war's end, exceeding Japanese production of all fighter types during the entire war. American fuel production could support unlimited flight operations, while Japanese aviation fuel supplies had been reduced to levels that prevented meaningful training or extended combat operations. American pilot training programs could replace losses faster than combat could eliminate them, while Japanese training capabilities had been destroyed by fuel shortages and facility bombing. The technological shock experienced by Japanese forces encountering P-51 seconds over their homeland extended beyond immediate tactical considerations to encompass fundamental questions about industrial warfare and national survival. Colonel Saburō Sakai, reflecting on the first P-51 mission over Tokyo, later wrote, "In that moment, watching American fighters patrol our capital city as if it were their own territory, I understood that we were not fighting an enemy air force, but an entire industrial civilization configured for our destruction. These aircraft represented capabilities we could not match, produced in quantities we could not counter, flown by pilots we could not replace fast enough. We were witnessing the mathematical expression of American industrial power, and mathematics does not negotiate. The profound realization that American single-engine fighters could operate over Japan with complete tactical freedom represented the final collapse of Japanese strategic assumptions about the Pacific War. Military planners had calculated that American forces would be constrained by the vast distances of the Pacific, that Japan's geographic isolation would provide defensive advantages that American technology could not overcome. The appearance of P-51 seconds over Tokyo demolished these assumptions with mechanical precision, demonstrating that American engineering had systematically solved problems that Japanese scientists had considered mathematically insurmountable. The production statistics surrounding the P-51 program revealed industrial capabilities so vast they redefined the mathematics of global warfare. American factories had produced more P-51 Mustangs than Japan had produced fighters of all types during the entire war. The United States had achieved this production while simultaneously manufacturing thousands of other aircraft types, millions of vehicles, and the entire infrastructure required to support global military operations. Japanese industry, operating at maximum capacity throughout the war, had proven incapable of matching American production of a single aircraft type, while American factories continued expanding output across hundreds of different military systems. The systematic destruction of Japanese airpower by P-51 escorted bombing operations achieved strategic results that individual aerial victories could not accomplish. By eliminating aircraft production facilities, fuel supplies, pilot training capabilities, and maintenance infrastructure, American operations created a self-reinforcing cycle of degradation that made Japanese aerial resistance increasingly futile. Each successful mission reduced Japanese capability to mount effective resistance to subsequent attacks, creating mathematical certainty of continued American success, regardless of individual Japanese courage or tactical innovation. The final lesson of the P-51's operations over Japan transcended aviation to encompass fundamental truths about industrial warfare and technological superiority. The shock experienced by Japanese pilots confronting American fighters over their homeland was not merely surprise at encountering superior aircraft, but recognition of their civilization's technological inadequacy when measured against American industrial capacity. The P-51 Mustang had not simply outfought Japanese aircraft. It had demonstrated the mathematical impossibility of Japanese victory through the systematic application of American engineering superiority, industrial capacity, and resource abundance. In the end, the appearance of P-51 Mustangs over Tokyo represented the ultimate expression of American technological transcendence. The demonstration that geographic distance, fuel consumption calculations, and range limitations were merely engineering problems to be solved through the systematic application of industrial mathematics. The Japanese pilots who first witnessed these silver aircraft patrolling above their capital city were observing not merely the arrival of another enemy fighter, but the physical manifestation of American civilization's ability to project lethal force anywhere on Earth with mathematical certainty that made resistance futile and surrender inevitable. The mathematical precision with which P-51 seconds swept Japanese fighters from their own skies established the template for technological dominance that would define military aviation for generations to come. It was a demonstration of industrial warfare so complete, so systematically overwhelming, that it permanently altered the relationship between technology, production capacity, and military victory. The shock experienced by Japanese pilots was not merely tactical surprise, but the profound realization that they had encountered a level of technological and industrial superiority that made their continued resistance not just difficult, but mathematically impossible.